Hello, this is a question from IBES level from chapter probability. The question says two ordinary fair dice are rolled and two faces on which they come to rest are hidden by holding the dice together as shown and lifted off the table. The sum of the numbers on the 10 visible faces of the dice is denoted by capital T. Find the number of possible values of capital T and find the most likely value of capital T, and also calculate the probability that T is less than or equal to 38. So basically there are two dice. One dice have six faces, so two dice have in total 12 faces. So when these two dices are kept on the table, the bottom two of their faces, they are hidden. Okay. Now two faces are hidden, so still we have access to 10 faces of two dice. So whatever the number are on the other 10 faces, we can still read them out, right? Only we are not sure about what are the numbers on two hidden faces of the dice. Okay, since they are fair dice, so they will have numbering from 1 to 6. Okay, so so what will be the sum of all the numbers? What will be the sum of all the numbers on 12 faces? So that sum on all faces of two fair dice, that would be 2 times sum of all the numbers on the on one dice. So that will be 1, 2 times of 1 plus 2 plus 3 plus 4 plus 5 and plus 6. So this is 2 times 21 is that is 42. Okay. Now they said that two faces are hidden, but we don't know what are the numbers and what are the sum of the numbers on two hidden faces. So let's say the sum of the numbers on two hidden faces be a plus b. Okay. Let a plus b be the sum of numbers with the sum of numbers on two hidden faces. Okay, if a plus b is the sum of the numbers on two hidden faces and capital T denotes the sum of only 10 faces. So we should subtract the sum of these two hidden faces from the total. So total sum on two faces that is 42, and out of 42 we need to subtract sum on two hidden faces, which is nothing but 42 minus a plus b. Now, other thing we have to find is what is the possibility that what will be the all combinations of sum of the numbers on these two hidden faces. So we'll make the cases here. Let's say the A is the first dice, and let's say there is one on the first dice. There is one on the first dice on the hidden surface of the first dice. So and let B be the second dice. So if it is one on the first dice, so let's then other dice may have 1, 2, 3, 4, 5, 6, right? Anything of them. Other thing you should be asking is what will be the minimum value of A plus B and what should be the maximum value of A plus B. So minimum value of A plus B can't be 1, because even if you take the minimum from both the dice, so least value that we can take is 1 and 1. So 1 and 1 is 2. So minimum value of A plus B will be 2 and maximum value will be 6 plus 6, that is 12. So let's make all the possible combinations. So when it is 1 on the first dice, so other dice may have 1, 2, 3, 4, 5 and 6. So then what will be the possible value of A plus B? So A plus B could be 2, 3, 4, 5, 6 and 7. That is when the first dice has 1. Now consider a second case. When first dice has 2, then second dice may have, second dice basically when I'm saying is the hidden face of the second dice. It may have 1, 2, 3, 4, 5 and 6. So then what will be the sum of A plus B? It will be 3, 4, 5, 6, 7, 8. Now case 3, when the first dice has hidden surface has number 3, then other one could be 1, 2, 3, 4, 5, 6. So then what will be the sum? Sum will be 4, 5, 6, 7, 8 and 9. Now third case, when the first dice has 4, then other one may have 1, 2, 3, 4, 5, 6. So then their sum will be 5, 6, 7, 8, 9, 10. Now, next case, when the first hidden face of the first dice, let's say it is coming with 5, then other hidden face of second dice, it may have any values from 1 to 6, right? So the sum will be 6, 7, 8, 9, 10, and 11. And the last case, when the first hidden face of the first dice is hiding number 6, then other one may have 1, 2, and so on until 6. So this will be 7, 8, 9, 10, 11, and 12. Clear? Now these, if you count all of them, they should be around 36. Not around, exactly 36. Now if you look, so the A part of the question was asking, find the number of possible values of t and find the most likely value of t. So what will be the possible value of t? So possible value of t, basically we denoted t as t is equal to 42 minus a plus b. So possible value of t will be 42 minus all the possible values of a plus b, right? And a plus b will have all the possible values from 2 to 12, right? So t will have all the possible values. 42 minus 2, which is 40. 42 minus 3, 39, and so on, so on. You go till 42 minus 12, which will be 30. And if you count them, they will be 11 in number. Other thing they were asking the A part is find the most likely value of t. Now, what should be the most likely value of t? It depends. The most likely value of t depends on the most likely value of a plus b. Got that? What did I say? The most likely value of t depends on the most likely value of a plus b. Now you count from your observation what is the most likely value of a plus b. If you see that carefully, you'll find the 7 has the most likely value. Okay, even if you can prepare a chart where you will find that, you find out the sum of a plus b and find out the frequency. So 2 will be coming once, 3 will coming twice, 4 will come 3 times, and some 5 will be 4 times, some 6 will be 5 times, some 7 will be 6 times, and then they'll start decreasing. Some 8 will be 5 times, some 9 will be 4 times, some 10 will be 5 times, no, 3 times, and some 11 will be 2 times, and some 12 will be only once. So you'll see the most likely value of a plus b is 7. How many times it will occur? It will occur 6 times. Now, if the most likely value of a plus b is 7, then most likely value of t will be 42 minus a plus b, which is how much? 7. So 42 minus 7 is how much? 35. So most likely value of t is 35. Clear? Now the second part, B part was asking, calculate the probability that t is less than or equal to 38. Now t, the formula, general formula for t was equal to 42 minus a plus b. Now they're asking what is the probability that the value of t is less than or equal to 38. So I can write this as 42 minus a plus b less than or equal to 38. Okay, now listen carefully. A plus b, now 42 minus a plus b should be less than or equal to 38, which means the maximum value of a plus b should be, or let's say what's the minimum value of a plus b can take. Can a plus b take 2? 42 minus 2 is 40. 40 is less than or equal to 38. No. So a plus b can't take 2. Can a plus b take 3? 42 minus 3, 39. It also can't take 3. So a plus b should be, can it take 4? Yeah, because 42 minus 4 is 38. So 38 less than or equal to 38. Yes. So a plus b can't take, a plus b can't take, a plus b can't take 2 and 3. Now how many times the sum a plus b is 2 and a plus b is 3? So a plus b 2 is 1 time, right? And 3 is 2 times. So if you count all these frequencies, they will come 36. Now how many times, how many frequencies are there that a plus b can't take value? So there are 3. 1, and then 1 plus 2, which is nothing but 3. So what the question was asking, calculate the probability that t is less than or equal to 38. So probability t is less than or equal to 38 will be 33 times 36. Why? 36 was total frequency, okay? And 33 is when the a sum of a plus b can't be this, can't be 2 and 3. So probably that t is less than or equal to 38 is 33 by 36. So sometimes the question of probability, they are not too much straightforward. You have to think, pause, and go step by step manner, and you have to basically make all the possible cases. I hope you have understood this.